In this course, you will learn how to build and deploy a RAG chatbot trained on your data. Anya Kubo will teach you how to implement the chatbot with LangChain.js, Next.js, Vercel, and OpenAI. You'll also use DataStax, who provided a grant to make this course possible.
If you're a beginner looking to get your head around AI concepts such as RAGbots, vector embeddings, and technologies such as LangChain, this is the perfect course for you. My name is Anya Kubo and I'm a software developer as well as course creator here on freeCodeCamp as well as on my own channel. And today I'm going to be your guide into the world of generative AI for JavaScript developers. By the end of this video, you won't just have a fundamental knowledge of the basics of AI development in JavaScript, you'll also have your own Formula One chatbot that can answer questions about the famous car sport that will give you the most up-to-date answers. You see, ChatGPT has a knowledge cutoff date of September 2021. That's when OpenAI stopped collecting training data for ChatGPT, so it is all the context that it has. We're going to scrape the internet in order to give our bot this up-to-date knowledge about Formula One. That's right, we're going to scrape the internet in order to get our chatbot to answer questions based on internet data as recent as minutes ago. We're going to do this with F1 data, but you could do it with any data that you can get your hands on, including your own private data that isn't available on the internet. This super slick chatbot will allow you to pick from some pre-made questions or ask your own ones. So you can either click on one of these options or type how much did Lewis Hamilton make in 2023 right here. Now, the best part about this chatbot, as we touched on, is that it uses your data and embellishes the answer using OpenAI to make the response sound more human or add on top of your data. What this means is that we will be getting our own data by scraping it from the internet, turning the text into vector embeddings, and storing those embeddings in our own personal database. On top of this meaning that we will get the most up-to-date responses, it also means that we won't be spending unnecessary OpenAI credits to ask our chatbots anything, resulting in us using it at minimal costs. But how can we be sure that this isn't just making a call to OpenAI, you ask? After all, we are still making a call to OpenAI as the last step to make the answer sound more human-like, right? Well, I will be adding questions that OpenAI will not know. By this, I mean questions that would need knowledge past September 2021 and seeing if the chatbot can answer them. So, for example, if I ask the F1 GPT RAGbot, who is the highest paid F1 driver? It will answer with Max Verstappen, is the highest paid driver, taking in a salary of $55 million in 2024. And if I was to ask the same question but disabling the access to our scraped data and just relying on ChatGPT, we would get the answer of Lewis Hamilton with $30 million in 2021. So, as you can see, it will truly be using our data. This means that once you master this chatbot, you can use it to answer questions about just about anything. Be it terms and conditions or FAQ from your own personal website to simply what your schedule is looking like. So pretty cool, right? A lot of real life use cases to incorporate a chatbot like this onto your own projects, and a lot of cool topics to learn on the way. In fact, here's a list of all the topics we'll be covering in this course. We will look at what is RAG. We will also look at our prerequisites for this course, including stuff like API keys. We will then look at vector embeddings and how they work, followed by a look at DataStax vector database management system, as well as OpenAI, and finally end with building our F1 RAG chatbot. So, what are we waiting for? Let's do it. What is RAG? Retrieval Augmented Generation, or RAG, is when you change the output of a large language model, or LLM, by providing the model more context alongside a user's input. That way, the model can use its ability to generate text along with extra context to provide accurate answers to users' questions. Large language models are trained on huge amounts of data and use billions of parameters to generate outputs for tasks like answering questions, completing sentences, and so much more. By using RAG, you are essentially extending the power of an LLM without needing to retrain it. But why is this useful? Well, it's cost effective for one. Usually a chatbot starts out using a foundation model that is trained on a very broad spectrum of data. If you then wanted to retrain the foundation model to answer questions specifically about your company, for example, computational costs, not to mention the financial cost of this, would be pretty high. Why not just add new data to the model instead, leaving in all the old data? Well, that is exactly what RAG does. Another reason to use RAG is that if the LLM you are currently using has a cutoff date as to the training data, you might need to top that knowledge up. You do this so that your bot gives up-to-date answers. As we saw, GPT-4 is only trained with data up to September 2021 at the time of recording. So if we wanted to ask who is the current Formula One World Drivers' Champion, it would come back with the answer Lewis Hamilton for 2020. Now, if you topped up that data by, say, scraping the internet information and scrape the list of Formula One World Drivers Champions on Wikipedia, that also included the winners for 2021, 2022, and 2023, the answer would be Max Verstappen for 2023. And finally, a third reason to use RAG is if the information does not exist on the LLM at all. So for example, the content of your personal diary, for example. You could top up the LLM's knowledge by adding the content of your personal diary, and the LLM will then know what you had for breakfast on July 6, 2018. Okay, so I hope that explains it. Now, let's carry on and do the steps in order to build out our very own F1 RAG app. Okay, so the prerequisites of this course, there aren't many, as the database management system that we're going to be using is free and will not be asking you for any credit card details or anything like that to sign up. So that's great. You will be needing the latest version of Node, so this is the version that I am using for this course. So please go ahead and update your Node version in order to continue. You will also need to sign up for an OpenAI account, but I will show you how to do that in a little bit. And of course, a knowledge of Next.js would be nice. However, I will be going through everything step by step. So if you're feeling brave, please go ahead and code along with me in order to learn. In this section, I'm going to explain to you what vector embeddings are in a super basic way. Okay, I say super basic as the topic of vector embeddings is really quite detailed and intricate. If you are interested in a deep dive on vector embeddings, I do have a course on this. Okay, it looks like this, so please do check it out. Otherwise, let's go for the super simple explanation. So a vector embedding is essentially a popular technique to represent information in a format that can be easily processed by algorithms, especially deep learning models. This information can be text, pictures, video, audio, and a bunch more. What I mean by this is that we can essentially take the text of cat and turn it into a representation that computers can understand that holds semantic meaning about the word. Okay, so all these little numbers essentially represent the word cat. Great, right? But how does this help a computer? So for example, let's have a look at the word dog, right? So here is a vector representation of the word dog. Now, all these little numbers essentially help a computer understand what words are similar to dog. Because for example, computers don't think like humans, right? If you were to ask a computer what word is similar to dog, it would most likely come back with a word that is lexicographically similar and come back with a word like dot. Thanks to these vector representations, a computer can now look at words like dot, like cat, and like path, and thanks to all the little numbers, figure out that dog and cat are in fact most similar in meaning. Pretty cool, right? Now, it's also important to know that each large language model will have different numbers, okay, representing words. So you can't really compare a vector embedding of dog using embedding that OpenAI made to another one that a different large language model made. So just keep that in mind as well. Again, if you are interested in this topic and would like a deeper dive into these numbers, then please do check out the course that I mentioned. Otherwise, let's carry on. Okay, so the first thing we're going to do is just sign up. So I've already signed up, but if you haven't, please go ahead and select try for free. So I'm going to sign in as I've already signed up, as I said, and all we're going to do is just choose to sign up with my Google account. So this will essentially take me to the dashboard, which looks like this. Wonderful. So this is what your dashboard should look like as well. Of course, I already have some recent resources, so previous databases that I have made. And if you want to create a new database, all you have to do is just select create a database here. And for today's tutorial, please make sure to select the one that allows you to work with vectors. So in this case, this one, the serverless vector database. So make sure that is selected, and then we're just going to name our database something. So as we are going to be working with Formula 1 data, I'm just going to go ahead and call this DB F1. Okay? And then you can choose a provider. I'm going to leave it as Amazon Web Services, but you have the choice of Google Cloud, Microsoft Azure as well. So now the region, just simply select the closest one to you. I'm going to go ahead and select US East 2. And of course, you can unlock new regions as well. But because we are just using the free version of this platform, we have one to choose from. Okay? So great. I'm just going to go ahead and create a database by selecting this button right here. So amazing. It really was that simple. We've just created a database in a few steps, and we didn't have to give our credit cards or anything like that. We are going to stick to the free tier of this for this tutorial. And just like that, we are done. This is currently pending, but once this is active, you will be able to interact with this a little bit more. So this is essentially your database. You can create collections in here that essentially hold your data, and that data will enable you to hold vectors in here too. Great, let's continue. Now, one of the things you will be needing for this course, as mentioned as a prerequisite, is an OpenAI account. So please head on over to openai.com and please go ahead and sign up for an account. So under products, under API login, that is what you're going to do. You're going to have to log in here. So please create an account right here, just like so. So I am going to come back. So all I'm going to do is click continue with Google, or if you don't have an account, please go ahead and sign up and just follow along with the steps. Okay? And once you are done, it should take you to a dashboard that looks like this. Now, when I ask you to select ChatGPT or API, if you select ChatGPT, it will take you to the chatbot. And the chatbot looks like this, so perhaps you're familiar with it. We will not be using this for this course, okay? Because we are going to be using the API in order to essentially communicate with the LLM instead, okay? So it's like we're bypassing this whole interface. What we are going to do instead is select the API, okay? So this is what your dashboard will look like. It will give you all the documentation that we're going to need for this course. So in this course, the models that I'm going to be using are the ChatGPT-4 model, so right here, and the embeddings model, which if you scroll down here under embeddings, is text embedding 3 small. Okay, great. So those are the models that we will be using, and the code that you'll be seeing today is simply taken from this documentation. One thing we are going to need from here is our API key. In order to do that, just head on over here, select API key, and you'll be able to create your own secret key. So that is something that we will be doing soon. Now, you might maybe have used this before and run out of credits. And in order to use this, you might need to have some credits in your account. So please head on over to settings and under billing, make sure that your credit card details are updated and you have purchased some credits, right? Okay, perfect. We should now be ready to go. Let's do it. Okay, so now it's time to actually start up our project. So please bring up your code editor of choice. I am using WebStorm, so if you're using WebStorm, please go ahead and get that up. And if you're not using WebStorm and you're using VS Code or something similar, I'm going to show you how to get started with that too, but it's pretty much the same. So first off, we have to create a project. I'm going to select a new project and I'm going to make sure to select Next.js because this is going to be a Next.js project. So in a directory I have chosen before, which is WebStorm projects, which lives on my computer, we're going to call this something. And I'm simply just going to call this Next.js F1 GPT. Okay. So great, that's what I've called my project. And we're going to use this command in order to create a Next app. And I'm just going to make sure that it's a TypeScript project too. Now, if you're not using WebStorm, you can just get up your terminal. So I'm just going to show you the steps for this, and then just go into a directory of your choice. Like I said, mine is called WebStorm projects, and hit enter. And then you can use this command. So I'm just going to copy that one right here. There we go. And then you can call your app whatever you wish. So it's npx create next app as one word with spaces here. And then you can just go Next.js F1 GPT, okay, and hit enter. But I'm not going to hit enter because I'm just going to hit enter from here essentially. So I'm going to choose to create my app, and it will spin up my application with all the configuration and files I need right in here. First off, it's going to ask me a few questions. So you'll be asked these questions too if you chose to hit enter on the terminal. Would you like to use ESLint? Sure, let's do it. I'm going to go with yes. Would you like to use Tailwind CSS? No, we're going to do our own CSS file. Would you like to use the source directory? I'm going to go ahead and hit no as well. Would you like to use the app router? Again, no, because it's just a simple app. We're not going to have pages to it. Would you like to customize the default import alias? I'm going to go with no, and wonderful. So amazing, that's it. It's now installing my dev dependencies. And great, success, that has now been created. We get a message of done. And if we look in here, we have all the files and configuration we need in order to get started. Okay, so let's just minimize the terminal. Okay, I'm just going to minimize it here, and let's get going. First up, however, I'm just going to delete some things in here. So maybe let's go ahead and do that. So first off, I'm actually just gonna, let's just start from scratch. Okay, so I'm gonna delete this whole directory called pages that has all these files. I'm going to put that in the bin. So let's go ahead and do that. I'm gonna go ahead and delete. So delete that like so. Let's also delete the public directory. Delete, we're really starting from scratch. And let's also delete the style. So a lot of deleting going on here. Great. Now we're going to just create 3 new directories, so on the same level as the README file. So just select the README file to make sure you're on the same level. Just go ahead and add a new directory called app. So there we go, we have app. We're also going to create a new directory, and let's call that scripts. So just like so. Okay, so we have app and we have scripts. Now in the app, I just want you to create some more things. I want you to create an API directory. So let's go ahead and create a new directory called API, just like so. And then also assets. So on the same level as the API, so select the app, new directory, assets. And this is going to hold all your images and stuff like that. So in fact, maybe let's drag those over for now. I actually have pre-made a logo. So I'm just going to drop that in. You can take it from, my project, or you can just create your own. So this is my F1 GPT app. This is what the logo looks like. And I'm also going to just drag in a background file. Okay, so there we go. Again, just feel free to make whatever background you wish. But essentially, it should have 2 files in here. It could be whatever file type, PNG, JPEG, whatever you would like. Okay, great. So the assets file is now done. We can make that a little bit smaller. The API directory, well, this is going to have another directory. So I'm going to make a new directory, and this is for chat. And we're going to write a root file in here. So let's create a file. I'm going to just go ahead and call it root. And it's a TypeScript file, so I'm going to go with TS. Okay, great. So once again, in the app, there's an API directory, which has a chat directory, which has a root file. So we can minimize that and minimize that. Wonderful. Now again, on the same level as API and assets, I'm going to create a new file this time. It's just going to be for all our CSS. So I'm going to just call it global.css, and it's going to hold all our CSS for this whole project. Like I said, it's not a super big project. I'm going to be focusing more, on the logic rather than styling up or anything like that. Cool. Now, again, on the same level as the global CSS file, so just select global CSS, we're going to create another file. This is for the layout of our app, and it's TSX file, as we're going to have JSX in there. So add that, and then we're going to add one more, which is just a page TSX, which is essentially going to hold the majority of our code for the application. Wonderful. Now that is it for now. We will continue a little bit later. We'll add some components in here too, but we'll do that as we go along. Now, I think this is good. Let's start off with writing some scripts, because we're going to essentially start off with loading data into our DataStax database. I'm going to do that with one script. So let's create a file. Again, this is going to be a TypeScript file, and I'm just going to call this loaddb.ts. Okay, great. Okay, there will not be any JSX in here, hence there's just a TS extension. Now, like I said, this is the file that's going to be responsible essentially for loading up all our data into our DataStax database, and essentially where we're going to scrape the internet for some information. So let's do it. So first off, we're going to start off with importing some packages that we need in order to do this. So let's go ahead and import them. We're going to need the data API client from a package that is called DataStax Astra DBTS. So that is one we're going to have to install. Okay, another one is to help us with scraping. So we're going to import, making sure to spell import correctly, Puppeteer, so Puppeteer web base loader from, this time, a package called LangChain. So LangChain, and then we're going to use document loaders web Puppeteer. So maybe let's just get rid of that for now. So that's two things that we need to import, and we're also going to import OpenAI from a package called OpenAI. As we know, we then want to essentially pass through our answers through OpenAI to make them more readable to humans, but more immediately to create vector embeddings of the data we'll be working with. Okay, great. Another package we're going to need actually is a .env. So we're going to import .env config in order for us to essentially hide our secret variables such as tokens and API keys and stuff like that, so that we don't have to keep them in this file. And if we upload this to GitHub, then we can kind of keep them secret. So great. One more thing from LangChain that we're going to have to get. This time we're going to import recursive character text splitter from LangChain text splitter. We are going to be using the recursive character text splitter from LangChain. When we load our data, we're going to be loading entire web pages which contain a lot of content, in this case about Formula One. When we ask LLMs questions, they work best when we feed them just enough context for them to give an accurate answer. So we will split up large bodies of text into smaller chunks that are more easily searchable and digestible. Great. I think that's all the things we need to import for now. Let's get up our terminal, and all I'm going to do is do npm I, and then let's import this one. So making sure to spell exactly the same, just like that. And then LangChain as well as OpenAI, right? So OpenAI, and then .env as well. So .env, and just hit enter. Okay, so now you will see in your package.json file, if we look in here, they should show up in this file along with their versions. So once that is done, you will be able to see them here. And great, that is done. And you will see those packages have been imported along with their versions. So this is really important. If you're watching this in the future and something does not work, it could be because you're using a different package. So for example, if you've just installed DataStax Astra DB and it's come up with, I don't know, let's just pretend this is way in the future, a 2, okay, then, you know, it might not work. I'm not sure. Unfortunately, I don't know the future. So just go ahead and change it back to a 1. Just see these numbers that you see here on the screen and change them to be the same and run npm-i again after saving the file. Okay, great. So once again, these are the packages that you should be using for this tutorial. Wonderful. So this is looking good. Now we do need to write some scripts. So I'm going to add a script to essentially run this file. So let's go ahead and do it. I'm going to call it seed, as essentially we're seeding our database with data. And for this to work, I'm going to use another package called tsnode, which will essentially allow us to read the file in the scripts directory called loaddb.ts. Okay, make sure to, of course, spell it the same. So loaddb.ts, and yes, it does live in the scripts directory. So now let's go ahead and install this package to npm-i tsnode. Wonderful. And that is now done. You should see tsnode show up in here. Great, so I think for now this is okay. I'm going to just get rid of that and let's continue. So now if I try do npm run seed and hit enter, of course we will get some errors. This is because we haven't configured everything properly yet. We can't use the import statement. So all you're going to do is go in here and in tsconfig, you're going to add just a little bit of code. So scroll down, I'm just going to scroll down here and let's go ahead and just add tsnode, and then I'm going to add compiler options. So compiler options, thank you, tab 9, and then module common JS. Okay, so just save that and get rid of this. And now if you run this again, everything should be working fine. We don't get any error messages. Great. So now let's continue. I'm just going to get rid of that terminal for now so we can continue with our loaddb.ts file. So first off, let's actually make sure we are connecting to our Astra database. And for this, we're going to have to essentially get some things such as let's go back to our Astra database. Okay, so what we're going to need from here is the database endpoint. We're going to generate a token, and then we're also going to get the namespace, okay? And the namespace we can get from the Data Explorer. We could just go with the default keyspace name. So let's get all this information, and we're going to store it in a secret file. So on the same level as the package.json, I'm going to create a new file. It's called a .env file, and we're going to store all our secret variables in here. So the first one, like I said, let's call this Astra DB namespace. And a namespace in Astra DB is the same as a keyspace as well. So default keyspace is what we're going to put in here. Default keyspace, just like that. Then we're going to also create a DB collection. So the collection lives inside the namespace, and R1 is going to be called F1 GPT. Okay, so that is the collection that we're going to have. And instead of going ahead and creating a collection in here, okay, so we could create a collection and then it'll show up in here under the default keyspace. We're actually going to do it from this project instead. So to be more specific, in the loaddb.ts file. So next up, let's also put in our Astra DB API endpoint so we can communicate with our database. So let's go ahead and get that. I'm just going to get that from here. So go to overview and copy this right here and then just paste it in like so. So that's my one. Your one will be unique. And then finally, we need a application token. So DB application token, just like so. And then I'm going to go back in here and we're going to generate one. So this is, again, just to be able to communicate with this database called dbf1. So let's copy it. You can see mine here. Please go ahead and use your own. So that's my one there. And great. We are also going to need one more thing, and that is an OpenAI API key. Okay, so that's one more thing. And to get this, you're just going to have to head on over to OpenAI. So head on over to openai.com. And then here, all I'm going to ask you to do is head over to the API. So let's go to API login. And then we're going to need the API here. And we're going to get an API key. So my one will be here. So just head on over here as well. And I can create a new one. So let's go ahead and call this secret key. You can call it whatever you wish. Create the secret key. And then I'm just going to copy it and once again, just paste it into my project. Now, if you use OpenAI a lot, you might have to buy some extra tokens. So just keep that in mind, okay? And please do not use mine. I will be disabling this once I'm done with this tutorial. Great. So that's really it. Let's continue. So now I'm just going to head over here and let's get all these variables into this file. So all I'm going to do is write, well, actually, maybe let's write it after this. So const, and then we're going to get a bunch of stuff from the env file. So in order to do that, we use process env, and we can only access the values we defined in the env file through process env because we have imported .env config. And we're just going to get everything from this. So we're going to get the namespace. So we're going to get the namespace from that file. We're also going to get the collection name, just like so. And then we're going to get the endpoint as well. So we can go ahead and get it like that. And then the application token. So just like so. And one more, and that is the OpenAI API key. So there we go. Maybe let's just get rid of that for now. And if you want, I can put these on a completely new line for you. So again, it is more readable for tutorial purposes. So there we go. Great. Maybe I'll make it a little bit bigger too. So great, we have all those things. So I think we're done with this for now. I'm going to shut this down. So now that we've done that, let's also go ahead and actually connect to OpenAI. So let's get OpenAI, and I'm going to use new OpenAI. So that's the import I have up here. I'm going to open it up and pass through an object, and that is just going to hold my API key, which is essentially, just get rid of that, the OpenAI key that I have here. Okay, so that is now passed through into the constructor, and now everything that OpenAI comes with, so the methods and properties that come with it, methods such as ones for creating embeddings, will be attached to this constant, okay? But we need to pass through the API key in order to use it. Otherwise, it won't let us access it without it, okay? So that's a personal API key that I can use. Great. Now let's actually define the websites that we want to scrape, okay? So because I want to get data that is past OpenAI's large language model cutoff point, so if you go back here and go to docs, and then we can go to models, and then the model that we're going to be using today, we're going to be using two, but for the actual text itself, we're going to be using GPT-4. So let's go ahead and select that one. And GPT-4 is only trained up to September 2021. So let's get some data about Formula One that is, you know, from the year 2022, 2023, and so on. So great. So for this, well, it would probably be useful to have you know, maybe some data that is updated, so like a list. So for example, maybe we go to the Wikipedia site. I'm just going to get rid of this for now. We can get rid of this for now. Wikipedia Formula One, because this will be updated quite regularly. So if we scrape this, we will get all this information about Formula One, which is quite a lot if you agree. So a lot of information here about Formula One, and we'll even have data that is much more up to date. Okay, so we'll even have new locations, including locations from 2022 to 2023. So let's definitely scrape this site. So I'm just going to put it in a string like this. Now I've already gone ahead and found some other sites for you. So you can choose to have the same ones as me, or, you know, you can take a little bit more time to find other ones to scrape, or, you know, if you're not even wanting to use this as a Formula One bot, you want to scrape your own data. After this tutorial, I would suggest, okay, so not while you're copying along with this one. Once you finish this, perhaps you want to create your own bot, then go ahead and, of course, feel free to put in all your own sites that you want to scrape. You will see most of them are Wikipedia. We have a few other ones. So we have one from, for example, Sky Sports that is talking about Lewis Hamilton's move to Ferrari from Mercedes. And then we also have information about history of female Formula One drivers and new information about Formula One highest paid drivers 2023. Okay, so a lot of stuff that is kind of interesting, I feel. Great. So now how do we get about scraping this? Well, what we're going to do is scrape it. But in order to scrape it, we're going to chunk it up, and then we're going to turn it into vectors. Then we're going to send it over to our database. So that's what we're going to do now. Let's get to scraping. So first off, let's actually connect to our database. So I'm going to create a client to do this. We're going to, again, use a constructor, one that we have imported. It's called Data API Client, as you will see here. So we're just using that here. And now in order to connect to our database, we're just going to pass through the AstraDB application token. So make sure, sorry, that says const client. And now let's connect to the actual database. So once we've defined client, once again, we can use a bunch of methods and properties that come with it, one method being DB. And now we can pass through the AstraDB endpoint, so DB API endpoint, as well as an object that contains the namespace that we want to be dealing with, which we know is, let's go Data Explorer, default key space. Okay, so let's go ahead and just pass through the AstraDB namespace that we saved in the env file. Great. Now you will see this coming up in red. Okay, this is because we have been very strict with our TypeScript. So if we go ahead and go back in here, I'm just going to save this file, go tsconfig. I'm going to put strict here as false and hit save. Great. So wonderful. That will get rid of these squiggly lines. Of course, if you want it strict, that's fine. It would just take a lot more TypeScript in order to get going, which is kind of outside of the scope of this tutorial. Now I'm going to split this up into chunks. So I'm going to define a splitter. And for this, I'm going to use the new recursive character splitter that we imported from LangChain. Once again, I'm going to pass through an object with some information. And we're just going to define the chunk size to be 512. And we're also going to define a chunk overlap, which I'm going to say is 100. Okay? This simply refers to the number of characters in each chunk. The chunk overlap refers to the overlapping characters between chunks. This helps us to preserve cross-chunk context. We basically want to improve our chances of the right information being retrieved and don't want the fact that we split everything up to have an impact on our results, in case a key thing was cut off a certain sentence or similar. So that's it. And now I'm going to create a collection in my database. Like I mentioned, instead of creating a collection here, I want to do it from this file. So in order to do this, let's define create collection. And this is going to be an async function. And all we're going to do is await db. And we're going to use the method called create collection. Let's assign this to const rest so we can see the response. And in order for this to work, we need to pass through the Astra DB collection name. So we've defined this as F1 GPT in our env file. And then we're going to pass through an object which has a vector. And we're going to give this a dimension size. So the dimension size, well, this is important because the dimension size has to match. Let's go back to OpenAI, products, API, login, API, and search for dimension. So here's the dimensions for the embeddings method. And for text embedding 3 small, the dimension is in fact 1536. So just to check this, I'm going to go to DataStax as well, go to docs and search for dimension. You will see that for OpenAI, it is 1536, okay? So here are other embedding models you could use, and they all have different dimensions. Just make sure yours are the same as the OpenAI one, okay? So great. And once again on here, you will see the default length and the embedding vector will be 1536. Great. So let's move on. Okay, so let's put that in 1536. And the metric as well, let's go ahead and put, well, there's a few we can put in here. So maybe let's define the similarity metric up here. I'm going to go ahead and define the type of similarity metric as dot product or cosine or Euclidean. Similarity metrics are used to compute the similarity of two vectors. When you create a collection in AstraDB, you can choose one of 3 metric types: dot product, cosine, and Euclidean. Cosine is used to determine how similar 2 vectors are and will be the default when creating a collection in AstraDB. It does not require vectors to be normalized. The dot product algorithm is about 50% faster than cosine, but it will require vectors to be normalized. When you want to find out how close 2 vectors are, the Euclidean distance is one of the most intuitive and commonly used metrics. If 2 vectors have a small Euclidean distance between them, they are close in the vector space. If they have a large Euclidean distance, they are far apart. I know it's a bit hard to get your head around, so please refer to these docs if you'd like to do some extra reading on the subject. I will put all 3 types so you can choose which one you would like to use in the future, but as a heads up, we will be using the dot product similarity metric soon. Okay, so now we have the type of this in TypeScript, and in the function here, we can pass through a similarity metric that has the type of similarity metric. And for this, we're just going to make sure that it is a dot product. Okay, so great. So now we can just pass that through as the similarity metric here. Wonderful. So when that is done, so right after this has been awaited, let's just console log out the response. So that is me once again creating a collection that is called F1 GPT, and we've already given the dimension size as well. Next, let's create a function that will allow us to get all the URLs we collected above, chunk them up, and create vector embeddings out of them so we can put them in our vector database. So let's write another function called load sample data. Okay, it's an async function as well, so just like so. And this time we're going to await DB collection because we've already created it above, and we're going to literally find the collection that we just created. So we're looking for it this time after we created it, and we'll just save it under the const collection so it's easier to work with. Now we're going to write a for loop, and we're going to await a few things. So let's define the URL, so const URL for every URL of my F1 data array, okay? And from each one, I'm going to create content, and for this, we're going to await scrape page, and we're going to pass through the URL. We are yet to write this function, but this function will essentially scrape each individual URL we pass through here. We're also going to create chunks out of it. So chunks. I'm going to use await splitter, split text, and we're going to pass through that content. And then we're going to loop once more for await const chunk of chunks. So for each chunk in my chunks, we're going to then pass it through the embedding. So we've chunked it up, and now we're going to create an embedding from it. So const embedding equals await OpenAI embeddings. So this is a method that comes with OpenAI, and we're going to create an embedding. So to create an embedding, of course, we need to define the model. And as we've discussed, the model we're going to be using is text embedding 3 small. We're going to import that chunk. So that's what we're going to create an embedding out of. And then let's also put an encoding format, which I'm going to just pass through as float. Okay, great. If you're wondering about this method that comes with OpenAI, once again, OpenAI embeddings. What are embeddings? And you will see here that essentially that is the same method that we use. And again, we're passing through the model, the input, and the encoding format. Great. So wonderful. And then, of course, we're going to get a response. The response is going to look like this. So it's an object that we're going to have to go into and get the data. And then this is an array. And we're just going to get that first item out of it, which is this. That also holds the embedding, which is an array of lots and lots of numbers, as we've discussed. That is an embedding. So let's go ahead and do it. The response, we should get that after this is finished. So maybe let's define that as a vector. We're going to go into the object. So we've defined this whole object as an embedding, right? So this whole object is an embedding. And then we're going to use data. And then we're going to go into the first object, like I said, and get the embedding. So once again, data, I'm going to go into the array, get the first object, and get the dot embedding in order to get that array. So my response should be an array of numbers, and that will be saved to the const vector. Now, once that's done, we're going to just await collection again, and we're going to insert that embedding for each chunk. So collection, insert 1, and then we're going to put in the vector. And as text, we're just going to have that chunk. Great. And then we can just console log out the response so we can see what's going on a little bit more. So wonderful. However, you might have noticed I haven't defined this function. I'm going to do that now. So let's do that down here. So const scrape data, making sure to spell that correctly, or scrape page, should I say, is an async function. We're going to pass through the URL as we've seen here. So let's pass through that URL. We can give this a type, so make sure that is a string. And now we're going to use Puppeteer essentially in order to scrape the page. Puppeteer is a JavaScript library that allows you to script and interact with browser windows. We are going to be using it today to scrape our websites. LangChain offers different options, including Cheerio, which uses a jQuery-like syntax to read things from pages, but because Puppeteer runs a real web browser, it lets JavaScript run in case that is important for content on the page. So new Puppeteer web-based loader, and this takes a URL, so this is just from the Puppeteer documentation, and then an object which has launch options, and this is an object. I'm going to put headless true. Let's save this as loader, so just like that. And then after the launch options, we're going to pass through go to options, so just like so. Wait until DOM content loaded. So wait till all the DOM has loaded. Wonderful. And after the go to options, we're going to pass through evaluate This is async. I'm going to pass through the page and the browser. We're going to await page, evaluate, and then a callback function, document, body, inner HTML. And let's save this as something. Let's save it as result. Then we await, browser, close, and return the result. We are adding launch options so that we can launch the browser in headless mode like I have done here. We have also added the got to options such as I did to wait for the DOM content to load. I have also added the evaluate function so that we can evaluate the JavaScript code on the page. This is useful for extracting data from the page or interacting with page elements. Okay, cool. And once all that is done, we're going to return await loader scrape. And if that exists, we can replace, this is just some regex with nothing. We are only interested in the text content so that we can feed it to our AI to create relevant responses. So we use the irregular expression to strip out the HTML tags from the page content. Okay, amazing. So once we've defined that function, I think it's now time for us to create our collection, right? So let's call that function that we wrote, create collection, let's call it. And then once that promise resolves, we're going to call another function. So this is a callback function to load the sample data, which is the other function that we wrote. Okay, so let's do it. Let's give this a whirl. Let's get up our terminal. I'm just going to clear that for us. Before we get going though, we do need to install the Puppeteer package. So make sure to install Puppeteer, as we are using Puppeteer and we have not yet installed it. So let's just go ahead and install that in order for this to work. Okay, so this might take a little bit, but once it's done, we're ready to run the seed script that we wrote. And we're going to do that with npm run seed. Okay, so npm run seed. And now this will take a while, right? Because we have to scrape a bunch of websites. So this will take a long time potentially. So please go ahead, have a break, make some tea, maybe go back to this in a bit. You will see it all scraping though, however. So once again, you will see the collection here has been made, F1 GPT in the namespace default key space. So if you go back in here and hit refresh, you will now see that collection show up. I'm just going to show you that. Whoop, there it is. So here we go. This is looking good. And of course, once it has data in here, so you will see the scraping is already working. It's creating a vector. So once again, an array of lots and lots of numbers. And we also get a vector ID and also the text that was essentially converted into this vector. Okay, so ta-da, we already have 9 items in here. And if we keep refreshing, there will be more. There's going to be a lot, to be honest. So ta-da, you will see more in here now. So this is what I mean by take a break. We're console logging out each one we insert. So once this is done, you will see this stop. Okay, so when that is done, you should see how many items we have in our data. We have over 1,000 records. Okay, so this is looking great. This is what it looks like. Let's move on. So now we're really done with this file. So I could just shut loaddb.ts down because we already have the data in our database. So now let's go ahead and build out the actual app. So first off in layout, let's go ahead and first import the style sheet. So this will apply the styling to everything. So global CSS. There we go. And then I'm just going to export some metadata. So export const metadata, just like so. Title of our project, I'm just going to put F1 GPT, just like so. And description, so this is just for SEO purposes. The place to go for all your Formula 1 questions. Okay, so there we go. Make sure to spell description correctly. And now let's export default the root layout. So all I'm going to do, we could write export default, or we could just use functional expressions. So const root layout equals, and then we're going to pass through the children as a prop. And then we're just going to return a wrapping element, which is going to be the HTML element, so just like so. And in here, we're just going to put the body. Okay. Again, we need the closing element, and then we're just going to put all the children. So just like that. And then we do export default root layout. So just like that. And lastly, I'm just going to put the language here, so lang en, and just like that, we are done with the layout TSX page. This is looking good, so let's just get rid of it. Now let's move on to the actual page. So like I said, this is going to be where the bulk of our coding for the app gets done on the client, so I need to define that. Use client in Next.js, and I'm going to do a few things. I'm going to import image from Next image so I can use it. Let's go ahead and import the logo. So let's call it F1 GPT logo from, and then we need to go into the assets. So just like that, and then get the F1 GPT logo. So we've done that. Next, I'm going to also import use chat from a package called AI from Vercel that we're going to have to install. So maybe let's go ahead and do that now. npm i AI. So just hit enter, and we can leave that to do its thing. The use chat hook from Vercel AI allows you to easily create a conversational user interface for your chatbot application. It enables the streaming of chat messages from your AI provider, manages the state for chat input, and updates the UI automatically as new messages are received. And we're also going to install something else, so import message from just AI. So now let's make our component. So const home is what I'm going to call it, just like that. And let's do export default home. And what should we return for now? At the moment, I'm just going to build out the structure of the web page. So let's make sure it's in a wrapping container. The first thing I'm going to do is just put the image in there. So here is my image that I've imported from Next.js. The source of this, well, I'm just going to use the F1 GPT logo. I'm going to set the width here to be 250. Okay, so we can put that just as a string. And then alternative text for this, well, I'm just going to put F1 GPT logo for the visually impaired. Great. So if we now run this, so I'm going to do npm run dev, and then go to localhost 3000, and let's get rid of that for now. Ta-da! There we have it. So it is working because we can see our logo there, and this is looking good. Okay, wonderful. So let's continue. So now under the image, I'm going to have a section. So let's put a section element. Once again, we're going to have an opening tag and a closing tag. And in here, we're going to show two things based on if there are already messages coming back to us from the chatbot or not. So for the time being, all I'm going to do is set no messages to true. Okay, we will be changing this later, but for now, I've just set it as so. So if no messages exist and this is true, we're going to do something. Okay, so we're going to do something here. We're going to show something, sorry, I should say. Otherwise, we're going to show something here. Okay, So those are the two things that we're going to show. If it's true, show that. Otherwise, show that. And what I'm going to do is for now just put an empty element here and an empty element here. So no message is currently true, so we're going to show this first. So for now, I'm just going to put a p element in here. I'm going to give this the class name so I can style it up of starter text. Okay, and in here, I'm just going to put some text. So I've already kind of written this out, so I'm just going to paste it. But essentially, this is what I put. The ultimate place for Formula One superfans. Ask F1 GPT anything about the fantastic top of F1 racing, and we'll come back with the most up-to-date answers. We hope you enjoy. So that's what I've done, and then I'm just going to put a break here. And then I'm going to show other prompts we can have. So, you know, if you can't think of anything, I'm going to show maybe like 4 here. So I'm going to create a component called prompt suggestion row that's going to hold them all essentially. Okay, of course we don't have that yet, so I'm just going to comment that out. Great. So that's it. So if we save this now, we should be able to see that. And our prompt suggestion row, which is commented out, is not showing up. Wonderful. So this is looking good. Now maybe let's work on if there are messages. So put this as false so that we can show whatever is in here. And here, so if there are messages, we just want to get the messages and map them onto something. Okay, so that's what we're going to be doing here. Map messages onto text bubbles. So we can do that later. And then I'm also gonna show a loading bubble. So this is something we can create. Let's make a component out of this. So that's another thing I'm gonna wanna create. Wonderful. Okay, so our 2 sections are now done. Of course, we won't really be able to see anything because I haven't actually put anything in there. I commented both out. And then after everything, so after all of this, right, just there, still in this section, however, I'm going to create a form. And this is essentially just so we can, you know, maybe ask our own questions that don't exist in the text prompt. So this form, I'm just going to put an on submit here. And this is going to handle the submit. It's going to have 2 inputs, so an input for text and then a submit input. So there's one and there's the other. This is going to have the type of submit, and this is going to have the type, well, we'll just leave it maybe as just a classic input. Let's give it a class name though so we can style it up a little bit more. The question box on change of this, we want to handle input change. The value of this is going to be the input, and let's also put a placeholder. So placeholder, and then we'll have the text. The text of this will just be ask me some thing ... Okay, great. So we've essentially kind of finished these things. However, the handle input change, and the input are gonna come from use chat. So we're not going to define them ourselves. They actually come from the AI package that we installed. I'm going to show you how this works, but essentially let's just get them first. So const input handle input change and handle submit all come from use chat, and of course we call it so we can get this. We're also going to get 3 more things, and that's append is loading and the messages themselves. And how this works is essentially we're going to create a route for our messages that we're going to write in the API directory, so in here. But we are yet to do this. First, let's get to styling this up so it kind of looks like a chatbot. So a break from the logic and just some nice styling coming up now. Okay, so let's do it. Before we move on, however, I'm just going to add one class name to this, and this is going to be dependent because I want to style the section based on if there's messages or not. So once again, I'm going to use this If there is no messages, and this is true, we don't want a class name to this. Otherwise, because there are messages, I'm going to give it the class name of populated. So wonderful. And maybe for now, let's just change this back to true. So now in the global CSS, let's start picking out these elements. So for my whole project, I want the font family of Verdana. And then as backups, I'm just going to have Tahoma and Helvet is fine. Maybe let's just have sans serif actually. Okay, and the body of the whole app, I'm going to just get rid of the margin and padding so we can start fresh. And then I'm going to initialize flexbox, and I've done this so I can center the actual main element, so the child element of this. I want to center it left to right, so I'm going to do that using justify content center. Then align items center, but this won't work without height, so I'm just going to go with 100 viewport height. Another thing I want to do is just add a background image, and I've already put this in, so this lives. We're going to have to find that. It lives in assets. So let's go to assets and then background.avif. Okay, so now if we look in here, this is what it looks like. However, like I said, we probably want to style this up a little bit nicer. So let's grab the child element of this, which is the main element. And the main element, I'm going to give it a width of 80 viewport width. The height, let's go with 80 viewport height. I'm going to move this up. The background color, I'm going to go with linear gradient. So let's just put a linear gradient to bottom. And then I'm going to make it kind of like this very off-white. So let's find F8, F8, F8 to this light gray, which is CF, CF, CF. Okay, so that's what I want as my background. There we go, let's get rid of the color. And now the border radius that I'm going to do is 15 pixels, just like so, to round it off. And once again, I'm initialize flexbox. I want everything to be in the center, so I'm going to do align items center. So at the moment it looks like this, but I want it in a column. So I'm going to do flex direction column and then justify content space between, so that everything is spaced out equally from top to bottom. So that essentially looks like this. Okay, the form, however, we need to take that out of the section. So let's go back here, go back to the page, and let's just grab that form and make sure it is outside of the section, so that now the three things are spaced out evenly from top to bottom. Great. Let's also put a padding of 20 pixels on the main element, and let's text align center, as well as change the color of the text to be an off black. So that's just a color I've picked out. Wonderful. So if you want to see what this looks like, it looks like this. Let's move on. Now, the section, which will always be there, is going to have a width of 100%. However, when the section has the class name of populated, so in other words, when there are messages in the app, then it's just going to change to a height of 100% display flex. And we're just going to make sure that everything's stacked on top of each other, so flex direction column, and showing at the end. So this time I'm going to do justify content flex end, and then I'm just going to make sure that we can scroll on the overflow. So scroll, okay, just like you would with messages. Now the starter text, so the element with the class name of starter text, so the paragraph essentially, I'm just going to give it a padding of 0 on the top and bottom and 80 pixels from left and right. And I think that's it for now. Maybe let's work on the form a bit. So let's grab the form itself. I'm going to assign it a height of 50 pixels, a width of 100%. Let's initialize flexbox once more. Let's just give it border on the top, so border top, and then this gray that I picked out, solid and 2 pixels. Let's give it a padding on the top of 20 pixels and let's round it off. However, I don't want a consistent border radius. I want to go 0 top left, 0 top right, and then 10 pixels rounded at the 2 bottom sides. Cool. And then overflow hidden. So that whatever we put in the form is kind of hidden outside that border radius. Great. Now I'm going to grab the input that lives inside the form. There was 2, remember. 1, however, had the class name of question box. And for this one, I'm going to say I want the width to be 85%, meaning that the other one, so the input, this one had a type. It didn't give it a class name, but we can just grab it by its type, just like so. This means that this width has to be 15%, so that they could be side by side. Okay? So that's what I've done. Let's also maybe give this a padding of 10 pixels. Let's also assign the font size to be 15 pixels. I'm going to change the color of this to be 383838, just like that. And then let's get rid of the border, so border none. And for this one, I think maybe let's also, I'm just going to copy these. So there is a bit of repetition. Sorry about that. Let's also give it border none. However, the color of this button, I want it to be white. So there we go. That's the shorthand for white. And let's also give it a background color. So F1 B8D. Wonderful. So this is what our app is looking like. I'm happy with this. It's looking really good in my opinion. Okay, one other thing I'd like to do is just get rid of the focus. So this is simple. All I'm going to do is grab the inputs to both of them really, and the focus I'm going to go with outline none. Great. So this is looking wonderful. The next thing I want to do is start creating some components for this. So let's go back here. I'm just going to open this up, and then in the app, I'm just going to create a new directory. Let's call this components, just like so. And in here, there's a few I'm going to make. We've seen some already. So the first one, I think let's create a bubble tsx file. So there we go. Let's create another one. This one is going to be prompt suggestion row.tsx, as there is going to be JSX in there. And the last one is going to be loading bubble, TSX. Okay, so there we go. So just make sure that they're kind of spelt the same. This is prompt suggestion row. I spelled the prompt suggestions row there, so maybe let's just add an S and let's continue. So the loading bubble, const loading bubble equals, let's just make a component for this and export default loading bubble, just like that. And of course, return something. So return just an empty element. And I'm actually just going to copy this. So loading bubble, prompt suggestions row. Let's change it to say prompt suggestions row, and I'm just going to copy that to here too, and then also save this. And for the bubble, let's just change this as well. So bubble, bubble. Wonderful. So now we can essentially import these into here. So I'm just going to minimize that for now. Let's go ahead and do it. Import bubble from, and then we need the path to this. So let's look in here, go to the components and get the bubble tsx file. Let's also import the loading bubble from components loading bubble and import the prompt suggestions row from the prompts suggestions row. So we've got those things now. So I can uncomment it out from here, and I can uncomment it out from here, and then we'll use the bubble here. So for now, obviously you won't see anything, it's just coming back with a empty element, but let's work on the loading bubble next, as this will be simple. So the loading bubble, I'm literally just gonna have a div, and it's gonna have the class name of loader. Okay, so that's all I've done. So we can get rid of that for now. And in here, let's pick it out. So I'm going to pick out the loader just like so. Let's give it a margin of 10 pixels, a width of 60 pixels. The aspect ratio, I'm going to go with 4. And now's the background. I'm basically going to use the background to create 3 circles. Okay, so I can do this by using no repeat radial gradient. So that one right here, it's going to be a circle. So make sure to spell circle correctly. Closest side. And then 38, 38, 38, 90%. And then 1, 2, 3, 4. 0%, 50%. Okay, so I've just done 1. I'm just going to do a few more. We actually don't need that percentage sign as it's 0. So copy that to 3. So we should have 3 here. There we go. And just put a comma here instead. And this time change this one to be 50%. So we're just spacing them out, and this one to be 100%. Great. Now we also need background size. So background size, it's a calculation of 100% over 3, then 100%. And now we need the animation. So animation, and let's actually define an animation. So we can call this loading, animation loading. So this animation, I want it to last for 1 second and be infinite and linear. And then let's actually do the animation, right? So at 33% of the animation, I just want the background size. So we're just going to be changing the background size, right? Calc 100 divided by 3 to be 0%, and then calc 100% divided by 3 to be 100%, and then it's just going to stay at 100% for the next one too. So there we go. So that's what's going to happen at 33% of the keyframe. Let's just do 3 more. So sorry, two more. So 3 in total. And at 50%, something's going to happen. And at 66% animation, something's going to happen. And I'm just going to flip these around. So we don't need that percentage sign. Let's change this to say 100%. And then this one is going to be 0% instead. So 0. And for this one, let's change this to be 100%. And this time, this is going to be 0. So just like that. So that's really it. So now maybe let's show it, right? So on the page, we just need to change this to no messages false so that it shows this one right here. And there we go. We have our loading bubble. However, we also only really want to show this if something is loading, right? So we can use isLoading from the use chat that we essentially imported. Is loading, and if this is true, then we show the loading bubble. So at the moment, obviously nothing is loading, so we don't see the loading bubble. Great, I'm happy with this. Another thing we can use from use chat is of course the messages now. So let's grab that. Essentially, if messages exists, we're going to map each message. So let's get each message onto something, right? And we know we want to map it onto a bubble. So there we go. We're also going to use the index because we need a key for this. So key And then you can just put index, or you could use backticks and write message index. So we can put this in curly braces using the $sign, so index. And then it will say which message index is, so the full string rather than just a number. And then we're just going to map out the full message onto it, so the full message like so. Make sure to map each message, make sure that says message. Cool. So of course this means that in the bubble as a child we're going to have the full message like that. Great, I'm happy with this. Cool, because we don't really know what this message object looks like yet, I'm just going to leave it at the moment. However, I am going to turn this into a div and give this a class name. And this class name is going to change depending on who wrote the message. So either it's us or the chatbot gave it back. So I will give it the class name of bubble, but we're going to be adding another class name to this depending on who wrote it. Great. So class name bubble, just like so. Let's also go ahead and start the bubble. So let's just go down here, or maybe let's just put it up here. Grab the bubble, and I'm going to give it a margin of 8 pixels, a padding of 8 pixels, a font size of 15 pixels, border none, color 383838, box shadow, not none, I'm going to give it a transparent color, 0 on the x-axis, 8 pixels on the y-axis, 24 pixels blur, a width of 80% of the parent, and make sure the text aligns to the left. Great, so we have our bubble. Wonderful. So now let's go back to the bubble. Okay, we'll come back to this. Maybe let's work on the prompt suggestion row next. So click on the prompt suggestion row component and let's do it. So on the prompt suggestion row, we're going to have some prompts. So let's define them, const prompts. Let's have 4. So I'm just going to have an array of them, and there's going to be an array of strings. I'm just going to copy this from ones that I've already picked out. So we have who is the head of racing for Aston Martin's F1 Academy team, who is the highest paid F1 driver, who will be the newest driver for Ferrari, who is the current Formula 1 World's Driver Champion. So those are my prompts, and I'm just going to map them out. So perhaps for this, we should map them out onto another component. For now, I am going to use a div in order to wrap those components. And I'm just going to give this a class name so we can style it up a little bit. So class name, prompt, suggestion, row. Okay, and then we'll map these prompts onto something. Let's create one more component, however, and I'm going to call this just a prompt suggestion button. So prompt suggestion button.tsx. So there we go. We have our prompt suggestion button. Once again, const prompt suggestion button. Thank you. Tab 9. Return. Let's just return a button for now, and export default prompt suggestion button. That's right. Now, what do we want this prompt suggestion button to look like? Well, let's give it a class name so we could style it up. I'm going to just go with prompt suggestion button, just like so. Let's also maybe give it an on click, because we want stuff to happen when we click it, right? So on click, we want to do something. So let's define our on click in the parent of this. So we're going to have to pass that down from the parent, so on click. And then we're also going to actually put the text, right? So the text that we've passed down onto the prompt suggestion box because we've mapped it out. Great. So if we go back here, let's actually get these prompts. So I'm going to get the prompts. I'm going to use map to map each prompt. Let's also use index. And we will map this onto, just as I said, let's get rid of this for now, the prompt suggestion button. But of course we need to import that. So let's just make sure this is a closing element like so. And import, that's been done automatically for me. Thank you very much. From the component prompt suggestion button file. Great. So we of course need to give this a key. So let's do that. I'm just going to pass through, let's use a backtick suggestion dash. I'm just going to put this on a new line for you so it's a bit more readable. We can see what we're passing through into this prompt suggestion button. Suggestion, and then let's have the index like so. So we've got a key for this. Next we need the text, and that's going to be the prompt itself. So the first time we map, we'll pass through this, which will then get passed through into the prompt suggestion box. The prompt will then get turned to text here, so we'll pass it through text, and it will be displayed in the button. So that's all we've done. Another thing we need to pass through is the on-click, right? Because we can define what happens in the on-click here, but I think we should do it from the page component, which means we need to also pass it down into here as a prop. Maybe let's define it as on-prompt click. So then on prompt click, so from the page, we have to pass through the on prompt click into here, and then that gets passed down into here, which we then pass down into the prompt suggestion button each time as the on click, which gets handled here. Great. Maybe let's do that next. So in here, let's actually define the on prompt click. To make it less confusing, maybe let's call it something else here. So handle prompt. Okay. So let's do it here. Const handle prompt. There we go. Now the handle prompt, well, what do we want to do? We essentially want to get whatever text we clicked in that button. So maybe let's save this for now. Let's go back here. Why is this red? Because we don't need to go into components. We're already in components. So we want to get this text essentially, right? And what do we want to do? Well, we just want to give it a random identifier as an ID, and we want to append it to the messages coming in. So let's define it. Let's create a message, and this message is going to be an object. And this object is going to take an ID, like I said, and it's also going to take content, and it's also going to take a role. So because we wrote this message, or we chose the message, I'm going to assign the role of user to this object. The ID we can randomly generate, so I'm going to use crypto random UUID to generate a random ID. And then the content itself, well, it's just going to be the text, right, that we clicked. So essentially, whatever text we click on the prompt suggestion box, so here, we need to save that in here, right? So how do we do that? Well, we just need to pass it up. I mean, we could pass it from here to this function, but however, as we are on this prompt suggestion row already dealing with the text here, we might as well do it here. So let's open up this function and pass through the prompt into that function, but this means this gets called immediately. So let's make it a callback function. So now we're getting whatever text or prompt we're choosing, we're putting it into this function, okay? But this function, of course, we've passed it down from the page, so we're dealing with it here. So now we can get that text here, let's call it prompt text, and assign it to the content. So hopefully that wasn't confusing for all you JavaScript or React or Next.js newbies. We could also give this a type. This type we have already imported already from AI. So this is the type of message, just like that, to satisfy our TypeScript needs. Great, so we just created a message, and I'm going to use append. Again, this is coming from use chat to append the message we just created to our existing messages. Wonderful. So now we also have what the message object is going to look like. It's going to have an ID, a content, and a role, which means that actually on the bubble, we know that we're going to get an ID, content, and role. So I can destructure this. So const, we don't really need the ID to be fair. So let's just get the content and the role from the message. Okay, and this just means I can get the content right here and show it in the text bubble, and also means on the class name I can now use the role to change what other class name I want to add to this. Or, you know, we could just say that, you know, if the role is user, then use that as a class name. So perhaps let's do that. So just like that. So if the class name is user, so if the element with the class name of bubble also has the class name of user, I'm just going to give it a border radius of 20 pixels on the top left, 20 pixels on the top right, 0 on the bottom right, 20 pixels on the bottom left. Let's change the background color. So background color to be RGB 225, 244, 255, and then we should probably have that in hex. So this is the hex value, as we've been doing hex throughout this. And then margin left auto. And then if the bubble also has a username of assistant instead of user, because assistant's the role that will come back if it's the AI responding to us, I'm just going to give the border radius of, just going to change the 0 here, so slightly change the border radius, and the background color this time is going to be DCE 7FF. Great. So we're done with the global CSS file now. We are done with the bubble. I believe we're done with the prompt suggestion row. I believe we are done with the prompt suggestion button. And on the page file, let's continue. So now we don't have to hard code no messages. We'll just say if there's no messages coming through to us from use chat, then that defines no messages. Or if message length equals 0, that also means there's no messages for us. Great. So wonderful. I'm now happy with all of this. Let's actually write our root next. So here is our root. Let's continue. I'm just going to shut that down. Okay, so now on the root, we're going to deal with actually sending stuff over, you know, from our database to our app, using OpenAI to make stuff more readable, creating embeddings, and so on. So let's go ahead and import OpenAI to do this. So OpenAI from OpenAI. We're also going to have to import OpenAI stream and streaming text response from AI. So the package that we used in our front end that essentially helps us with managing messages, managing inputs, and so on. And we're also going to import data API client from DataStax Astra DBTS. Wonderful. So once again, we need to get a few things in, and those things are the variables that we also used in the backend. So maybe let's go ahead and get our script. So the load DBS script, and I'm just going to go ahead and copy all of these. So copy all of these and just paste them once again like so, because we're going to be using them in this file too. So first off, once again, hopefully this is some muscle memory for you. We're going to connect to OpenAI. We're going to use the constructor. We're going to pass through an object, and that object contains the API key that we need in order to communicate with OpenAI. So here is our OpenAI API key. And next, we're also going to have to connect to our database, right? So let's create a client for this. New client, new data API client, so just like so. And in order for this to work, we need to pass through the Astra DB application token. Now let's actually connect to the database itself. So for this, we use the client as well as all the methods that come with it, one of it being DB, and we need to pass through the Astra DB API endpoint as well as an object that's going to contain our namespace. Okay, so we know the namespace already. Astra DB namespace is the default key space. And there we go. We're pretty much connected now. So now we're going to write a function to export async post. This is going to help us write a post request. We're going to pass through the request, and then we have a request type from TypeScript. So that's just what I have added here. Of course, we need to actually define this as a function. There we go. And we're going to try some things, and we're going to catch any errors. So catch error console. Let's console log it out, actually. Console log. You could console log the error. We could do some generic like error querying db ... It is up to you. Great. So the thing we're going to try to do, we're going to try to do quite a lot from the request JSON. So request JSON, we're going to call that, but it's an async function, so we're going to await for the response. And from the response, we're going to get the messages, okay, that come back. Now we just want to get the last message, right? So const last or latest, maybe message, because that's the one that we want to essentially create an embedding out of. So we're going to get the messages, all of them, and to get the last one, well, I think maybe the easiest thing to do is get the messages length and -1 from it. So just like that, and get it content if they exist. So there we go. Now let's also define the doc context of what we're going to send over. And at the moment, I'm just going to let it be an empty string. So doc context. And let's go ahead and await OpenAI embeddings create. And then we're going to create an embedding from what? Well, from the latest message. So we need to pass through, as we saw, the model. We also need to pass through an input. So just like so, an encoding format. So the model we're going to use, as we know, is text embedding 3 small. The input is just going to be the latest message that we wrote. And the format is going to be float. Cool. So once that comes back to us, I'm just going to save it as the embedding itself. So there we go. And once we have the embedding, we're going to try something else. I'm going to await DB collection. I'm going to pass through the Astra DB collection because we're literally finding the collection, right? And once we found it, we'll save it as the collection that we are working with. And we're going to find something that's similar in our database to whatever we wrote here. So if I wrote Lewis Hamilton, we've essentially passed through Lewis Hamilton as the last message. We turn it into a text embedding, okay? And now we're going to look in our database for something that's similar to Lewis Hamilton. And to do that, we're going to grab the collection. We're going to do find null. I'm going to pass through an object that's going to help us sort for the 5 or maybe 10 most similar things. So sort, let's get the vector. And then we saw what the embedding object looks like, right? It's an object that has data, an array of data. So let's get the first item and get the embedding from it, which was the array of lots of numbers. And then we're just going to limit this answer by 10. So we're going to get 10 similar items. Wonderful. So that is looking good, and we probably need to catch errors for this. So perhaps let's not bother catching errors for the last one. I think let's only catch errors for this here. So just like so. Error querying DB. So if we don't find anything back, that's where we query the database. However, let's save this to something. This can be cursor. So now once we have the result of this, let's change it to an array and save it as document. So const documents equal. So we have our potential 10 documents. So if documents exists, I'm going to map each doc. Just get the doc text. And let's call this a docs map. Great. Now I can get the doc constant, and at the moment it is nothing. However, I now want to assign it a value. I just want to assign it the value of the docs map. So now that we have some doc context, and of course if this doesn't work, so let's just set it back to an empty string again, we can essentially send over the template of what we want to send over to OpenAI. However, we do need to await this, so there we go. That is also an async method. Great. So now that we've done that, so here, let's define our template that we're going to send over. So this role is going to be system. And the content that we want to send over to OpenAI is, I'm going to just send it over. I'm going to use backticks, however, I was going to use code in here. In fact, I'm just going to paste this and go through with it with you. So my template looks like this. It's got the role, and then the content says, you are an AI assistant who knows everything about Formula One. Use the below context to augment what you know about Formula One racing. The context will provide you with the most recent page data from Wikipedia and the official F1 websites and others. So that's what I fed in. If the context doesn't include the information you need, answer based on your existing knowledge, so OpenAI's knowledge, and don't mention the source of your information or what the context does or doesn't include. Format responses using Markdown where applicable, and don't return images. And then we've added some context. So that context is essentially the dot context we defined. So in other words, the 10 things that came back from our database. So then we're feeding that in. We're starting context, we're ending context, we're sending this all over to OpenAI. And then we also have the original question that we asked, okay, in text, not an embedding. So that's what I want to essentially send through to OpenAI. So let's do it. So after this, I'm going to use a method from OpenAI called chat completions. So await OpenAI chat completions. Create. And this time the object we're going to pass through, well, once again, we need the model. I'm going to stream this, so put true. And the messages that we're going to pass through, well, it's going to be our template as well as all our previous messages, okay, including our latest one. And let's go ahead and define the model. As we said, we're going to use GPT-4 for this. Great. And let's get the response of this. So const response, just like so. And now that we have the response, I'm going to pass it through OpenAI stream. Response, and save this as something, so const stream, and I'm going to return it. So return, make sure that's a stream. Return new streaming text response stream. Okay, and now we're going to catch errors. So catch error, throw the error. Cool. So that's it. I know that was kind of lengthy, and we used a bunch of stuff that you're probably not used to, like methods from OpenAI, as well as methods from Astra, but hopefully that kind of makes sense. So let's check it out, right? Let's go back here. Of course, we have these. Perhaps let's quickly style them up a little bit. So let's get rid of this now. Let's just get our global CSS file. Let's get the prompt. Maybe this makes me bigger so you can see it. I'm going to get the prompt suggestion button and say that its margin is going to be 8 pixels. Padding, 8 pixels, font size, 15 pixels, border, none, background color, FFF, so white, border radius is going to be 10 pixels, color is going to be 383838. And the box shadow is going to be one that I've already used previously in this project. So I'm just going to write it out again. 5330, x-axis 8 pixels, y-axis 24 pixels, blur. Cool. And finally, we're just going to get the prompt suggestion row and make sure that its width is 100%. So great, this is looking so much better. Let's go ahead and try this out. So who will be the newest driver for Ferrari? So I've just selected that prompt, and we did feed in some data about Lewis Hamilton being the newest driver for Ferrari. So there we go, this is good. He is set to drive for the Italian team until at least the end of 2026. So this is because we fed in data from our database. Okay, if we didn't pass through data from our database, so for example, let's get rid of that. And also let's amend this so that it does use OpenAI data. So I'm just gonna get rid of that. And let's go again, who will be the newest driver from Ferrari? So once again, we're not using our database. We're expecting an answer from OpenAI. So there we go, currently Ferrari's driver line of a 2002 season, and then we have that who joined Ferrari in 2021. So you will see that data is out of date, essentially. So once again, this is an answer as if it was just using OpenAI, okay? As if you were just asking OpenAI to answer the question along with this content. So you are an AI assistant who knows everything about Formula One, format response using Markdown, and then we're just feeding through the question of who will be the newest driver for Ferrari. We're not using our data, okay? So in order to use our data, we of course need to add that dot context. And I've added a bit more here. So OpenAI just uses our dot content and, you know, not itself as much. Great, so hopefully that makes sense. Let's try it again. Who will be the newest driver for Ferrari? So because, once again, we fed in data when we loaded the scripts, and this article in particular, Lewis Hamilton says move to Ferrari from Mercedes doesn't need vindicating. So this Sky Sports article would contain news about his move to Ferrari. As you can see, we are getting a response like this. Lewis Hamilton will be the newest driver for Ferrari. He has a multi-year agreement with a team that runs until at least the end of 2026. So great, we've proved it. And of course, we can then continue to ask more questions, such as, what does he think about the switch? You know, and then submit it. So if we fed in the data about this, then our bot should be able to answer questions about it. And it says Lewis Hamilton seems to be confident about his decision to switch for Ferrari. He has stated explicitly that there hasn't been a moment where his question. So essentially it's answering the question based on data we fed in. Great. Let's try another one. So once again, should we see who is the current Formula One driver? And it says the current Formula One world driver champion is Max Verstappen. What year is this for? Question. Based on the most recent data, it's for the year 2024. So how up to date is this? I am currently asking this in the year 2024. Great. So hopefully that makes sense. Please have fun with this. You can, of course, go ahead and ask any questions you want. Just be aware that, you know, the amount of data you feed into this is important. The more data you feed in, the more accurate these responses are going to be. And of course, the more data you will have. So perhaps you want to scrape more articles. That is up to you. However much time you have, you can scrape as many articles as you want. I hope you've enjoyed this. I hope you've enjoyed building this with me. And of course, now that you've mastered how to build an F1 chatbot, please feel free to build whatever kind of chatbot you wish.